I want to welcome all of you to engagement. Thanks in your being a Saturday. It's 10 a.m. in Kampala, Uganda. I don't know what time it is. Those listening in from area, those listening in from Canada, you're all thank you, thank you, thank you. Straight to the point, this engagement is surrounding the power of artificial intelligence in engineering practice. This is harnessing artificial of AI. Two, to demonstrate practical applications of AI in engineering design, project management, construction supervision, and engineering scrutiny or assessments, in which the layman calls them audits, the accountants. Three, to showcase AI tools that can enhance productivity, efficiency, decision-making in engineering, and decision-making in engineering practice. Four, to discuss the opportunities, challenges, and ethical considerations that come along with AI in engineering specifically. And finally, we want this to act as an inspiration to all generations to embrace digital transformation and continuous professional development in this dynamic. And it's based on that we have a brief agenda today that started with registration and logging in. Next will be an opening prayer and welcome remarks that will be from the branch chairperson or one of the members that will be present. We shall collectively agree on housekeeping rules where need be, and there will be opening remarks and the official launch of the webinar by the officiator, who is none other than Engineer Peterson Mwesige, the president of the Uganda Institution of Professional Engineers. And at this juncture, I would like to recognize his presence and thank him for giving time to come and be with us and inspire all those listening in from across. And then we shall have an introduction of the speakers and the topic. Straight away, we shall go into technical presentations by both presenters. One will be Christopher Sabiti, who I want to thank also for accepting our invitation to be a part of this engagement. And two, engineer, I prefer to call him Femi, for also honoring the invite all the way from Nigeria. And that will be between 10:15, supposed to have started, 10:20, sorry, starting in the next 3 minutes, to 11:52, when we shall have the takeaways. We shall wrap it up with announcements of upcoming programs and events from the Uganda Institution of Professional Engineers, both at the secretariat and at the branch level. And finally, a vote of thanks and closing of this engagement. That will be our agenda. We had set some expectations. We shall also hear from the audience on their expectations of the event. At this juncture, I want us to go straight to an opening prayer. But before we do that, I just want to find out Engineer Ochen Willie, chairperson. I think he has not yet come in. Okay. Just give me a minute to follow up on that, and then let me see who is coming in here. Okay. Let's have an opening prayer, which I will volunteer to lead. Loving Father, we are grateful for this day. We are grateful for the opportunity of life, the opportunity that you have given us to all be here to have such beautiful discussions. Father, as we have the discussions, please be our ministers, give us the guidance, the knowledge, and the courage to all participate in a constructive way. We ask all this through Christ our Lord. Amen.
Amen.
Am I audible?
Amen.
Wonderful.
Yes, you are.
That's encouraging. Straight away, are there any house rules that members suggest we should keep? Let's agree in 1 minute. Let's come up with something, collect. Chris, do you have any suggestion, anything in mind? Okay, we want to try and have this engaging. Straight away, in the interest of time, I think we shall be going straight away to the opening remarks and the launch. And at this juncture, I would kindly welcome the president of UIPE, who will give us both the welcoming and opening remarks and officially launch this webinar. Thank you. Mr. President, you're welcome. think there should be some lapse of network there.
Yeah, I think
Engineer Peterson?
we can't hear from him.
Engineer Peterson, I hope you are not speaking with a mute microphone. Just kindly give me a moment to try and establish exactly what's going on. Colleagues, just give it a moment. I think he has developed a small problem with the laptop, but he's trying to join in with the phone. In the meantime, okay. Engineer is trying to join in there. You can see the camera. In the meantime, we have a link to try and capture any missing information. So please feel free to have it filled once again, such that we capture, especially your professions, because we appreciate the fact that members who are non-engineers, some are associates of engineering, would love to be a part of this. So in order for us to streamline the communication, we have developed that form, which is in the chat, for members to fill in those details. Moving forward, it will guide us on planning. Engineer Peterson, is it okay now?
FX, can you hear me?
Yes, we can hear you, but with echoes. Probably both microphones on both devices are on.
Okay, so the echoes should have gone by now. Is that better now?
To me, yes. Maybe from other members we can hear.
Okay, thank you very much. So may I proceed?
Yes, you may.
Okay, thank you very much, colleagues. It's a pleasure to join in this morning to discuss this topic, which is very timely. First of all, I would like to thank you all for making time to be here and join in this conversation, but also to thank and congratulate West Nile branch for organizing this important webinar. So kudos to Engineer Ochen Willie, our chairperson, but also to Francis Bicky, FX, who has been like the main coordinator of this, coordinating and engaging us. So we are very grateful for putting this together. And while at that, in terms of the UIPE framework, the Uganda Institution of Professional Engineers, the idea is that we should have more of these events happening at the branches. And as a matter of fact, some aspects of the registration function as well. So we, as the council, we did come up with a branch devolution policy, which in a sentence means that we want as much as possible to decentralize so that most of the things are happening at the branches. because that is how we grow the institution. So this is consistent with getting the branches doing most of the things. So we are grateful that West Nile branch is taking the leadership. I would also like to take the opportunity to congratulate FX Biki, who is our branch honorary secretary, for being elected to council to represent all the 8 branches on the UIPE council. Colleagues would know that under our new constitution as UIPE now, the 8 branches of the institution select 3 people to sit on the council to represent all the 8 branches. And that election happened on Thursday. Maybe the announcement is not yet made, but I'm aware that FX was one of the 3 colleagues who were elected to join us. So I'd like to congratulate you and to say how happy we should be to have you on council, both on behalf of the branch, but also really on behalf of all the 8 branches, especially for the energy and zeal and vigor that you carry. So I'd like to congratulate you for that, FX. Also to welcome our speakers, our facilitators for today. That is Sabiti Christopher, PMP, and Engineer Adefemi Ademei, who is from Nigeria, which is a very special place because the Ghana Institution of here and our leaders were always traveling to Nigeria to attend the event. So it is a pleasure to see an engineer from Nigeria, and we hope that we can even get more of our engineers speaking in your events, because we've enjoyed these fraternal ties for a long time, and we were very proud that Engineer Shehu was able to rise and become the first president from Sub-Saharan Africa to become the current president of that is Engineer Butelezi from South Africa. And this September, when we host the Africa Engineering Weekend Conference, which will be in September in Dar es Salaam, and the details will be shared, of course, through our usual channels. But we shall select one. But there's also the World Federation of Engineering Organizations, which is now the world body for all engineering organizations. So Engineer Shehu was the first African to become the leader of that body. So we are very proud, speaking of the relationship that we enjoy with Nigeria. And so you're most welcome. We are very glad to have you. The theme is, as I said, very timely, because AI has permeated everything that we do. I mean, the nature of transformation that we are talking about is like when you talk about the first industrial revolution, you know, steam engine, you know, mechanical power, electrical power, industrial, you know, information age, artificial intelligence now, a very fundamental revolution. And again, without spoiling what our experts are going to share, but I wanted to say that even as we have these conversations about AI, especially for the professional colleagues, for the engineers, even for the students, I hope we have students on the platform. At the very least, you must understand AI as a tool, as an enabler. When cars were introduced, because I think before cars, before the engine, people were using raw power, which is like you get on a horse and you move. Okay, so then the engine was a very fundamental transformation. And there would have been people who would have said, we are moving too fast. Okay, so every time you have a transformation, there will be people who actually oppose it, who are comfortable with the status quo, with how things have been. So there will have been people who say, no, 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 we cannot. First of all, cars are dangerous. So they will say many things. They might say cars are very dangerous. You know, we are going to kill all the children in the community because cars are going to knock people. So you can say all those things, but the truth is that the revolution will go forward, notwithstanding your conservative ideas. So I think the approach for every change, but also really for this kind of change, the revolution. And I hear some voices. Incidentally, I work in the academia. So I know that even in the academia, we are struggling to adjust the new realities. And there'll be voices who embrace it and see it as a tool, as an enabler, so that it can enable us to do our work better. But there will be people who say, well, we are killing the education system. That's not my view. Writing one report for 1 week. And with AI, I can write 10 reports in a week. Then so be it. I've just been enabled. So I hope that AI is a tool and that we just have to, like any tool, I mean, even like vehicles, we have to think of responsible use. How do we use it responsibly? So it would be the same thing for AI. So I would like to once again say that the conversation is very timely. I'm excited. I'm looking forward to so much learning and to see how we pick lessons. And the final thing that I would say, even before I close and open, because I know I'm supposed to close and then declare the webinar open, is to say that as the Uganda Institution of Professional Engineers, we are very excited to host this event. We are very excited for the support from our key sponsor, Uganda Bati, who has always supported branch activities. I remember I served on the council between 2010 and 2012, but I also served on the branch executive of Kampala branch between 2014 and 2015. And for as long as I have been at UIPE, so I would like to thank you very heartily for supporting the institution, but also for supporting the branch activities. And I know that in many ways, we return that support as well to Uganda Bati. So we ship, and I pray that we shall strengthen that. Then the very final point I would say is that when we took over leadership 1 month ago as the new leadership at UIPE, we decided to say that the mandate of the institution is to give a voice, is to give a platform to the profession, to give a voice to the district engineer, to give a voice to advocate, to influence, to reach out and quote unquote, make noise on behalf of the profession, make sure that our challenges are recognized and acted upon. And in that spirit, we have promoted our public engagement. You will notice that we have just made an announcement. I think it came in yesterday that we'll be hosting a monthly platform, which we call the UIPE Voice, which has been advertised on all the platforms, and we'll see more details coming through. The idea is that our members do not have to wait for the AGM
Mr. President, is it my network?
No, I think we lost
We
him.
all lost him.
We lost him.
Oh, sorry.
FX, I think you lost me. Confirm that you can hear me now.
Yes, we confirm we had lost you.
Yes, we can hear you.
Thank you. So I was sorry. I was finalizing, and I was saying that I don't know whether you had did you hear my point about the UIPE voice every last Thursday of the month at 10 a.m.? Did you hear that?
Not fully.
Okay. So let me just make the point that as the leadership at UIPE, we have taken a strategic decision to increase the engagement that the institution has with its members, but also with the public out there, with the stakeholders. And one of the avenues is to host a monthly engagement, a platform really, where we address the media. So we have engaged all the media houses across the country. But at the same time, we speak to the members, but you also speak to stakeholders. So this would be an event where, number one, we tell you what is happening in your institution, what we are doing, where the challenges, and we also hear back from you. But at the same time, it would be the stakeholders. If anyone wants to speak to the engineering fraternity, they come and speak to us. You know, if the Inspector General of Government has this perception that engineers in districts are corrupt, they will come and speak to us and we speak back to them. So it will be a platform of engagement, and we hope that we shall then take leadership on shaping conversations in our space, which I think has been lacking.
Did we lose engineer again?
Yeah, I think he has challenges.
Am I
He has
audible?
challenges with his network. Yeah, you're
Okay.
audible. FX, you're audible.
Yes.
He has challenges with his network, so
I think I'm back. I think I'm back.
Wonderful.
So thank you. So I was saying that we'll be hosting that event, and then the final point I would put across is that the other strategic decision we have made is to treat city engineers, basically our engineers in local governments, as a special category because they have unique challenges that need to be addressed in a specific manner. So we'll be putting out a call to have engagement with them and discuss their issues and support them. So with those very many remarks, I would like to once again thank you, Branch Chair, Engineer Chen Willie. Thank you, FX. Thank you, branch members. Thank you, our guests, and officially declare this webinar open. Thank you, colleagues. May God bless you.
Bless you too, engineer. That was wonderful and very vital information. Thank you for giving me the opportunity to serve at council. Straight away, we are starting our sessions, but we want to begin it with the expectations. We set some expectations for this discussion, and should there be any that have been missed, then I encourage members to put them in the chat box. We shall be able to view them and respond to them. And one of the expectations, one, is introduction and definition of AI, demonstration of its practice in the different domains, in the built environment, the professional considerations, and the preparations, how prepared we are for the future, just like as it was stipulated in the objectives. And at this juncture, allow me straight away invite the first speaker, Christopher Sabiti, to take over from me. Sabiti, you're welcome. Sabiti is a distinguished AI and data analyst, a coach, and a founder of one of the online platforms. I believe he will give us details into the AI about him. Thank you. Sabiti, you're welcome.
Thank you, FX, and the team that has managed to join. We apologize for the hiccups due to the network connectivity, but we shall be there. I will share my screen, then I think we can kick it off. Just give me a yes if you can see a screen with a welcome note, then I will take it off. Okay, FX, am I introducing myself, then we have a Defemi, or I kick it off straight into the presentation, just for your guidance?
You can kick it off straight into the discussion, and then Femi will also come in at an appropriate time.
Once again, good morning, everyone, and a warm welcome to this webinar. I was excited and I couldn't have said no when you invited me to speak to the engineering fraternity. Actually, most times I don't introduce myself as someone who was supposed to be on the other side. I hold a diploma in electrical engineering, not until technology and computer pulled me 10 years ago, and that was the pull. So here I am, and the person you're seeing, Christopher Sabiti, I found Subtech Online a decade ago, where we have been running a lot, making people skilled in all techs, forms of tech, that is coaching in data, product skilling and systems development, project management, projects in tech, and name them. Today we are going to focus specifically on how AI has been, it is, and is going to be in engineering practice. First and foremost, to pass a disclaimer, whoever is listening, when we hear of AI, our minds straight away think about ChatGPT, Cloud, Gemini, name them. Now, I think after this call, it's where we are going to differentiate where each lies and how we should always use the tools. As the president has already said, these are the tools that are supposed to enhance what we are doing. We are not here to fight what AI or what the developments are bringing to the emerging trends we are in technology. Every day we wake up, something is new. Yeah, even at the end of this call, I would love that when you enter your office on Monday, you should be able to identify at least one workflow Perhaps a weekly schedule update you have been running with your team, a structural calculation you have been reviewing the whole day, a Monday, that you will now start thinking of having an AI assisted tool which could shorten this from the days you've been using to run a report to hours. And I think that should be the main expectation. Then going forward, when you know that something exists, you always have the urge to learn more and more and more. So Christopher comes from PMP fraternity, that is PMI fraternity, that is Project Management Institute, where most of the engineers also subscribe. And I have most of the people here coming from the Subtech online community, like I have Virunji, Ibra there. I name them, I know there are very many in the back end, but I appreciate that you honored this. Being that even you felt like I'm not an engineer, but let me go and listen in. Somewhere, somehow, we always need to know, even though we don't practice. Okay, so we are going to listen in for the next 3 minutes. I want us to run through this video. And the video is going to take us through how things used to be done in the 90s and how things are being transitioned quickly, and that's where we shall jump in for the AI assisted practices. Okay, we'll start the video right away.
For most of the 20th century, designing the physical world was a manual marathon. Our most iconic bridges and highway systems were drafted by hand, using physical reference books, ink, and thousands of hours of human calculation. This era relied on a reactive philosophy. Engineers designed for the worst-case scenario, construction teams built it, and maintenance crews essentially waited for components to break or show visible wear before intervening. Keeping these assets functional required constant, exhausting physical labor. Teams had to walk thousands of miles of track and climb hundreds of towers just to identify where the next failure might occur. But the scale of modern infrastructure has outpaced the speed of human intuition. Between the thousands of sensors on a single bridge and the complexity of global power grids, we have reached a point where traditional manual management can no longer process the information necessary to prevent failure. In the last decade, we added digital sensors to almost everything, but this created a data bottleneck. A smart city grid generates millions of status reports every hour, information that would bury a human team under a tidal wave of noise. Artificial intelligence acts as the filter for this noise. Specifically, machine learning models analyze years of historical records to find the subtle patterns that precede an equipment failure, turning raw data into a predictive timeline. Generative AI takes this further by creating entirely new designs. By defining goals like load capacity and budget, engineers can use these models to simulate and test thousands of structural variations that might take a human months to draft. Computer vision provides the eyes for the system, automatically spotting cracks in concrete from drone footage, while digital twins create a virtual NERDA system that mirrors the health of the physical asset in real time. Engineering today focuses on building dynamic, self-reporting physical networks that communicate their own status to the people who manage them. In the traditional design phase, manual revisions were a major bottleneck. Producing even a few viable options for a complex project often took weeks of CAD work and individual stress calculations. Generative design replaces that linear process with simultaneous simulation. An engineer sets the constraints and materials, and the AI generates hundreds of valid structural options, testing each one against safety standards in seconds. When the engineering firm Arup needed to design a large-span stadium roof, traditional methods yielded only 3 viable designs over an 8-week period. Switching to an AI-driven approach changed the math. In just 72 hours, the system generated 347 valid variants. The selected design reduced required steel mass by 28% and cut the design cycle from 8 weeks down to 3. This process allows engineers to explore a mathematical possibility space for load distribution, that human designers would likely never discover through manual iteration. During construction, project management has traditionally relied on reactive reporting, checking spreadsheets and blueprints to see what went wrong after a delay has already occurred. AI shifts this towards predictive control. Models trained on thousands of previous builds now flag potential cost overruns or schedule slips up to 6 weeks before they happen, giving managers time to reallocate resources. On the ground, drones scan the site daily. Computer vision algorithms automatically compare the as-built progress against the digital design, detecting clashes where a pipe and a beam might conflict before they require expensive field corrections. Modern project controls provide a proactive radar, identifying root causes for delays while there is still a window to mitigate them. Once an asset is built, maintenance typically falls into a calendar-based routine. Parts are replaced every 6 months or after a certain number of hours, regardless of their actual condition. Predictive maintenance uses IoT sensor data to eliminate that guesswork. By monitoring vibration and temperature, machine learning models can predict an exact failure point, allowing a team to replace a bearing only when it hits 85% wear. Network Rail uses this technology to monitor 32,000 kilometers of track. By identifying geometry faults before they require speed restrictions, they avoid the cascading delays that used to define reactive rail maintenance. This data stream also facilitates continuous auditing. Instead of waiting for an annual inspection, AI systems cross-check emissions and safety records against regulatory standards 24 hours a day. A finished infrastructure project functions as a live data source, alerting engineers to its specific needs long before an inspection would find a problem. However, an AI model is only as reliable as the data that feeds it. If the historical records are incomplete or siloed, the model will produce flawed recommendations. Clean data governance has to exist before the automation starts. Connecting industrial control rooms to cloud networks also introduces new cybersecurity risks. Infrastructure that was once physically isolated is now visible to a global landscape of digital threats, requiring a security framework as robust as the engineering itself. Deploying these tools without strict governance doesn't remove risk. It simply allows a flawed system to fail at a much larger scale. If a predictive model recommends a structural delay that eventually leads to a failure, who is accountable? The engineer, the software developer, or the organization? An algorithm cannot hold a professional license or take legal responsibility for a design. Contextual judgment and ethical accountability remain the exclusive domain of the human engineer. This requirement is creating the T-shaped engineer. These are professionals who maintain deep expertise in core disciplines, like structural or electrical engineering, but also possess broad fluency in data analytics and automation. This shift is opening up new career paths, from digital twin engineers to asset intelligence analysts, which focus specifically on the intersection of physical systems and data science. AI will not replace engineers, but engineers who master these tools to design smarter, more resilient systems will inevitably replace those who do not.
Okay, I think you have heard that. That is a statement I love to hear, and I think it is all over, where they say AI is not going to replace anyone in the profession they are in. The only thing that AI will replace is the people using AI will replace those people who have not learned the skill of AI, because as we speak right now, every tool is being manufactured right now with an assistance or with an integration of AI, because it is the way to go. By the end of the day, the human judgment, intuition to decide relies with the professionals, because you carry the license. The AI or the system that has been subscribed by the organization or the business you're working with has no license, and it can't go in court because a loss happened, people died. At the end of the day, it is you, the engineer, who takes the decision. When AI does its models and predicts a report, you, the license holder or the professional, that's where you come in to internalize the report produced by AI. And that's why we need to start shifting in skilling, that whenever you have electrical engineering, a honors, a master's, you need to have an AI fluency, that you can know what is wrong and what is good when a report is produced or when an analysis is done by a language model or an AI assisted machine. Okay, guys, what is AI in engineering? So what we should know from this session, that AI is machine learning, where we teach the artificial intelligence, we train them with the data that machines run with right now. If a machine has been running for 20 hours and you put it at rest for 5 minutes, that is what you're training the AI or the model that you're applying to that machine. And going forward, that's what it will take. Whenever it is doing an analysis, exactly, it has learned that that's how the machine runs. So what we are going to look at briefly, how do you explain AI? If someone asked you, what is AI? What we should know that AI is a simulation. It learns from human intelligence. It processes everything from what it has learned from the machines, especially looking at computer systems here. So these processes include learning, reasoning, and self-correction. So AI is not there that it is doing things on its own. Whatever we are doing right now with AI, we are training it better. It means that every day that comes, AI becomes better and better and better. So those who used ChatGPT 2 years ago, last year when it was going viral, right now it has changed. If you have been using it, you'll testify that there has been changes because we have trained it to do better. Baiki, maybe to confirm there are people joining, I think you'll admit them since we are running it together. Now, in the tradition, we started with people doing everything. Then we came to the people collecting the data, sitting down, analyzing the data, having the reports done, analyzing the reports, then they seek for approvals from the bigger hierarchies. But we are going into the AI models that assist in doing all that. And at the end of the day, it is giving us the insights, which make you, the engineer, to have smarter decisions. At the end of the day, you are the one who makes the decision. And that has prompted us to have safer infrastructures at a low cost and in the shortest time, if you have done that in project management, cost, scope, and time. So, being that we have known now what AI is, a simulation of, it simulates human intelligence. These are the three evolutions engineering has gone through. The first in the 1950s, maybe for the starter, AI was first introduced in 1956. The word artificial intelligence was invented in 1956, if you read the history. So those who say that AI just came yesterday, it has been there. We have been using it. We have been using Google Maps. But we have hyped it now to a level that it is going at a rocket speed, of which we have to curb it, learn the skills. So we started traditionally where we used to do the manual drafting, the calculations, the paperwork on projects, reactive maintenance only. You have had the video that you'll always come to work on a motor, or you'll always come to work on a cracked bridge when the bridge has already cracked down. But shifting, we started looking at the data. I know with engineers, you know that when a bridge is put together, you know that after 5 years, we have to replace this part and this part. We have seen roads, after a given number of years, they come and remove the layers and relay again. We, or the people who have not had the engineering knowledge, like they ask themselves, why is the government removing what again they are putting? But that is all in engineering that is under maintenance. So that was all to do with data. Now we have moved into a level of AI assisted, where we are having generative design and simulations done by AI itself. It simulates a bridge. I will use an example, real example, like our Ginger bridge. It simulates the bridge. It computes all the materials that will be required. The time that should have taken architects and engineers to do that in like 8 weeks, it will be done by AI to collect all that data in less than 3 weeks. And it continues doing the surveillance, even comparing them with the ISO standards 24/7. So as we still say that it starts with people and ends with people. The people used to do the work. We went to gathering the data and simulating it into different reports and analyzing them. The intelligence came on board and we are here with it. So we remain with the other part still with us, the professionals who hold licenses, that is making decisions after the intelligence tools have given us the reports. So engineers who don't use AI obviously will be replaced by engineers who have used AI and have learned AI in few years to come. So this session is here to tell you that from tomorrow, start looking out how you can upskill. Sliding forward, I will just try to make it quick for the matter of time. Let's look at the engineering AI tool belt. The simple way you can take it, we start with the physical sensors. Every machine will always have sensors. And even right now, most of the machines, most of the structures we are putting up, we put sensors. The sensors to do different jobs. Those sensors are there just to learn the patterns, what that infrastructure is doing. If it is a motor, it will run the number of hours, the vibrations, and how the heating capacity, the cooling capacity, all that. The moment all those learnings are done, it will always descend that data into, obviously, we are having now the cloud data lakes. A cloud data lake is a repository where we keep data like sensor data for a motor or for sensors we have put on different buildings. So after we have had machines learn whatever we want them to learn, then we come now to the computer vision. We have had now drones inspecting and processing complex visual data. A drone is driven from here to Ginger, inspecting the Ginger Road. And it is going to mark crack it will find on the road. In 3 hours, the drone will have already told us that we have 2 million cracks that are on Ginger Road, and every spot is being visualized in the report that we have a crack in Mukono, we have a crack in Seta, we have these cracks in. That is computer vision in detecting and flaws when we prepare maintenance. Then we have generative AI, where we find the intelligence models. I know we have architects on the call. You have had a lot of AI enhancements in the tools you have been using, like ArchCAD, where right now you no longer do the hard work you used to do a decade ago. So some of the things are just prompted, and in 2 days you have already produced a plan that you used to architect for over 2 months, a decade, or even a year ago, before you learned maybe to use those AI tools. Then we have digital twins. Digital twins are those people who have done interior designing, who are using those tools, that they render the way how the physical space is going to be. They do a rendering of a bridge, the way how exactly the bridge is going to be, even before they put the foundation. That's what we call digital twins. You render the machine how it is going to work before even you go to start clearing off the ground where you're going to put the machine. So this is where now we build on engineering to enhance it with AI. Just remember the belt where we have the physical sensors, we keep the data in our cloud, we have intelligence models like Power BI, a lot of tools outside there that simulate and analyze that data. Then it comes back to the engineering applications we, the professionals, are using, because you're supposed to take the final decision. Here, that's where you find the arch cards, you find the SCADAs, you name them. Then I will let's look at the macro forces that are restructuring our industry. How has the industry responded? I can tell you we have a lot of investment that is going on in AI. Most companies have invested in these models. And when these companies invest in the models, it means that every tool you touch is going to be having an AI assisted view somewhere, somehow. So we have smart infrastructures. Obviously, I can say now approximately there has been an investment of over $2.5 trillion in IoT. IoT is Internet of Things. Internet of Things is anything you can use to do the work. It is an Internet of Things, so long as it accesses internet somewhere, somehow. So this has been connected on roads. You'll find we are going to find some of the roads. They have those spots they put on the road, such that every vehicle that passes, it is like a hump. It records the weight of the vehicles that use that road. It means that at the end of the day, in the background, they are analyzing data on when they can repair that road. If they have to repair that road, this time how many layers should they put? How the capacity of and the strength of the materials to be used. We have AI robotics. When people hear about AI robotics, our minds run to these robots we see that are built like people. But robots, anything that is used to do work that a human can do, and it is a machine, it's called a robot. If you have a pen that you just point at a paper and it starts writing automatically what you're thinking, that one is a robot. So going forward, don't think robots are the ones that are built like human structure, the ones we see all over the internet. So we have like 2.7 million that has been invested units deployed across structures. Last week I was watching a video. I'll share those links maybe with Baiki. I was watching a video where they were testing a robot to weld underwater. You know those propellers on ships, when they break or they crack? A person has to go there. They may spend even 2 weeks. A ship is stationary, not until the welding is done. But now a robot can do it in less than 3 hours. Descends kilometers under the waters to weld all these cables, internet cables we have running all overseas. So that has increased on safety. It has reduced on cost. It has reduced on the risk that people have been having, because we know people die under those high pressures. The generative design, where we have tested a lot, mostly on we had the traditional time frames where we create designs and it goes through a lot of iterations to have it approved. The digital twins have talked about that. We have the autonomous inspection. You already have AI assisted tools that are inspecting the whole plant every 24 hours. You have data that you should have had by 30 engineers deployed in that plant to move around the plant from space to space. Obviously, it comes in with an improvement, a plus and a minus. Then the predictive analytics, as you have had the video, and we know most of us, we repair something after it has broken down. But now with AI assisted, it simulates you even to repair a machine when it is 80% to break down. It tells you that your phone is no longer supporting you, please dispose it off and buy another one, something like that. So that's what is in engineering right now. So when we talk about that, let's look at the mathematics of generative designs. We have had in the video that for a structure of a bridge, an engineer is used to create 3 versions and they analyze them to approve out one. But here they are telling you that AI is going to load the requirements, you load the limits, you load the materials, you as an engineer. It can do 347 variant simulations. It can simulate for you how the Ginger Bridge should be in design and create for you 347 designs, which would take even months for engineers to create. And the more they increase, the more the choice of decision becomes hard. But this can be done in only 72 hours by the AI-assisted generative AI-assisted generation designs. And even it does for you the tests and gives you the best options depending on what variants and prompts you have given it. So that's a case study, which I think we have already heard from the video. Okay, now here we skip a bit on project management. Yeah, every engineering practice at least has engaged themselves on a project. And in project, we have aspects we look at. Here we look at the schedule performance indicators or index. How long is it going to take? Do we have delays? Then on the cost performance, every project that starts always starts with a budget. But are you going to go over and above the budget? Are you going to fail, consume the budget because at the end of the day, the project halted and failed? Or at what risk exposure do you have? So in simulations, the AI assisted, this is where it runs. And all this, when you look at this in project management, this one is on schedule, the cost performance is aligned with the budget, and the risk is okay for any project you can run with that. And it will always give you alerts. Now, such will be like a report that is produced already by the AI assisted and an analysis done by the different data that is collected by the different AI assisted tools. But when you come to projects, you are assisted on scope management. It assists you on cost management because most of the things will be readily and predicted for you. Then also on resource planning. Yes, I know when we talk about machines, we say we are reducing on the people. Yeah, we are reducing on the people, but it doesn't reduce the people as how we think. It may reduce the manual labor, but the people will always be there in hand to make decisions for these machines. Okay, the continuous assurance I should give. As we have already said, we start with reactive. Before in tradition, we used to run with a reactive. The asset fails, fix when it is broken, and you never plan for this downtime. You know how downtimes cost the businesses and manufacturing plants. Then the preventive, you have a fixed time interval that every 2 weeks you have the data from whichever sensor data you're getting from the tools you have installed and you replace on schedule. Then the predictive, this one, sensor data threshold, it tells you that AI predicts that you're now 85%, 15% remaining for you to use this motor until you rewind it. So, or you change the bearing, or you do this. And you'll always do this in time. Or for those manufacturing plants where you have to do a customized print of a certain machine from the factory or from the manufacturer, you do it earlier, such that by the time it lands, you know that it is ready for replacement. I've been in a plant where we had a breakdown and we spent 2 weeks without operating that section because that machine had to be customized from the manufacturer, and the report went there or the request went there after the breakdown had happened. So where we are right now, those are things that shouldn't happen. Overlook you as the engineer or you as the profession meant to supervise that. Yeah, for the continuous loop, you'll always collect the data using the IoT sensors, the drones, and all that cameras. AI will analyze this for you, engines, and here they tell us that it will keep the ISO standards into copy when it is doing its analysis 24/7. Then you'll identify the risks and you'll always have the reporting done, make the decisions, and that's how the loop will always run. Okay, I've had discussions with people that, machines are coming, they have their problems, we people can't be replaced, I have had discussions with that. Some groups who have had like a full day trying to convince someone that, what, AI is not going to replace you, but just learn it. So this AI comes with its constraints. First of all, on data governance. If AI is trained on poor data, it is going to produce errors with confidence. That's where they say garbage in, garbage out. Cybersecurity, we have the SCADAs, the IoT integrations we have done, but at the end of the day, it comes with hackers can access your SCADA with ease. So which means you have also to elevate your security to do with the tech. The security on the tech side, I'm not saying the security guards on the gate, no. So which means you have to beef that up. Then regulatory reliability. AI doesn't look at the regulations Uganda has set yesterday in parliament. It means that you have to keep retraining it. Otherwise, you'll find you as an engineer, you have used the machine to do something which has already been prohibited by the government. That's where the human symbiosis comes in. That what human can't do, repetitive calculations, pattern detection, you can't detect patterns, but machines will detect the patterns. Continuous monitoring, we may not do continuous monitoring. We need at least to sleep 4 hours a day as human. Yes, human retains the professional engineering judgment. I repeat this, professionals retain the judgment, the ethical accountability, the creative way of solving problems, and stakeholder leadership and management to do off the final sign-off. The president has already talked about this. Use AI as a tool to enhance whatever you're doing. At the end of the day, you're there perfect. So I can conclude this by saying that AI will not replace engineers, but engineers who use AI will replace engineers who don't. Don't be surprised engineers coming from university right now replacing you with your 30 years of experience because businesses are shifting, manufacturing plants are shifting, constructions are shifting. So we no longer talk about the experience that you have been on ground, but the experience with skill on the emerging trends that we have right now. That is not scaring, but it is preparing us for where we are going. So I have put together here what a future engineer should be. We have deep core expertise we already having. Structural, mechanical fundamentals. You have all the PMI methodologies with you. You can spit them out even when you're in a dream. You have all the risk and safety measure, certifications and all that. But at the end of the day, we need now to complete the T. That you need to start looking at how do we analyze data? How do we create reports? There are things to do like SQL and data querying. We are populating a lot of data using these sensors, using these drones. This data has to be analyzed. Even if you analyze it using AI, you have to take the decisions, but you can't take decisions from something you don't understand. So you start learning the Python basics. Python is a language that is like natural language. You speak and the system gives you what you want. Machine learning concepts. How do machines learn? patterns. Let's start learning that, such that when a machine fails and it is AI assisted, you know where to touch. Then you need to learn how data is kept in the cloud, how you use the Internet of Things awareness. Obviously, we shall share this with you in the follow-up email for you to take a read. Learn how to use ChatGPT Cloud. We have Gemini, we have Copilot, we have Grok. Try to use them. They all come with a free package. Use them to automate some things. And by the way, we hold classes at Subtech Online. You can reach out whenever you feel like you're stuck. Try to see how they develop or they put together Power BI reports. Then start applying that. After like 3 months, you'll already be having fluency. Start applying it on the different tools you're using. If you're an architect, try to use AI in your AutoCAD. Then by the time you reach 9 months, you'll now be learning the AI governance, the digital twin integration, how you can simulate a motor that you're going to install somewhere, how it is going to work, the vibrations and everything after you have installed it. Otherwise, when you do that, you'll be better to go. This is just examples telling you where AI is being used. We have looked at bridges, and here we see every point of the bridge has sensors to do the predictive bridge maintenance, where a report is populated on every morning, such that you know that this pillar is supposed to be replaced after 3 years because it is already developing a crack. And that crack will be always monitored by a drone that comes there every morning that is AI assisted. Then when we go to construction, you know, in traditional concrete, you used to put in all that concrete for it to be strong. But now there is that optimized composite that we have seen the 3D printing, the way how it is being done. So all that will reduce on cost, it will reduce in weight, it will even increase in strength, and obviously sustainability. Otherwise, that is what I can say. I know we have a lot of questions that we have generated. I will give it off to Defemi to take us through the AI in electrical engineering and renewable energy. Then we shall come up with the questions. Please stay on the call. A lot is coming and interesting. I give the mic back to the chair, FX. I will drop my screen for now.
Wow, that has been a masterclass. Little did we know that AI was being applied into our engineering programs. We usually studied the MATLAB, C++, and we said, when will we ever use this? But now, given the tool belt we have come to appreciate personally, I have been able to appreciate where AI comes in. And I encourage all of us to pick that up, just like you said, the number of questions, but using the AI in me, I've been able to establish that we are 27 minutes behind schedule. However, before I call on the next speaker, I just want to re-echo, we have a link that is in the chat. Let's fill it and fill the missing details, because on the call, we have come to appreciate that a number of stakeholders have joined us from all disciplines. And at that juncture, I want to recognize, I can see Engineer Godfrey Ezama calling in from Arusha. We have just Engineer Paul Rachkara, the chairperson of Gulu branch, calling in from the city of Gulu in the northern part of Uganda. Rwamwizi Innocent, thank you for joining us. He is one of the vice presidents of the Project Management Institute, which is a global network of project managers, but with a chapter in Uganda. I think about 24 chapters only in Africa, in which Uganda is one of them. Engineer Zabo, Thank you for coming in. Nagawa Jackie coming in from the capital Kampala. Douglas, who is a representative of the students, PMI. Thank you for joining in. I've seen Pamela, who is also one of the VPs of the Project Management Institute at an appropriate time. I think, Innocent, just before we close, you'll be given an opportunity to say something. I've seen Engineer Bahati calling in from the USA. Thank you for joining in. Engineer Pario Bernard, who is one of our chapter, who is one of our branch executives, Gladys. Thank you for calling in. And we have Jemima, who is an ambassador. She's the Ugandan ambassador. Allow me call her that, of road safety in the country. Welcome to the call from the capital, Kampala. At that juncture, allow me invite Engineer Femi. Please, you're welcome, and you're welcome to Uganda, one of Africa's fastest growing economies. Thank you. You're welcome.
Need to present my slide. Please confirm you can see my screen.
Yes, we can see your screen.
Good morning, my fellow engineers. We'll start by saying thank you to Engineer Peterson, President of Uganda Institute of Professional Engineers, Oshunwili, and the entire West Nile branch, my moderator, and every engineer who logged in this morning. Thank you for having me join this this webinar. So I would start by saying that a number of people must have asked this question. Sometimes my colleagues, younger engineers, and even colleagues who are not engineers. And the question is that will there be a place for us with this evolution and the trend on artificial intelligence? And my honest answer would be reiterated in the next couple of minutes. As my co-speaker said earlier, AI is not after electrical engineers. Engineers who work quietly to learn and upskill with intelligence. So in today's webinar, I will show you some areas of electrical engineering where artificial intelligence are already being applied. So I would also like to tell you that the World Cup is currently on the way. We're in day 3. There's something that is already being used in the world of football, which is called VAR. If you are hearing the word VAR for the first time, VAR is just application of artificial intelligence in reviewing human decision. And so VAR would be one of the key decision maker on every football event in the World Cup. And AI will be reviewing human decision and also will be breaking heart in real time. So if you are ever shouted at a VAR call, congratulations. And I'll tell you that you already have a strong opinion regarding VAR. So once again, thank you for having me to be present with very, very important engineers in Uganda. My name is Adeyemi Adefemi. I'm an electrical engineer, project engineer also, project manager also. I work at the intersection of renewable energy and power system. I've been building renewable, more importantly, solar BSS powered microgrid across Nigeria. Various in power system and how power system can be properly. I stand in between renewable energy integration, building power systems, project delivery, and adding AI in ensuring that some of these delivery can be done much more efficiently and faster. On the engineering side, I'm a member of the Society of Engineers, also a licensed electrical engineer from the Council of Regulation of Engineering in Nigeria, and also I'm a certified project manager from Project Management Institute. In today's session, I divided my workflow to show you artificial intelligence application, more importantly, in power system with a much more definite focus in renewable energy systems. Also, I'll be showing you a couple of demonstration where AI has been applied in different workflows. How do we stay relevant in our very engineering profession with the use of the various artificial intelligence tools? And then I'm going to be taking questions from different participants. Just a quick review of what artificial intelligence, as also mentioned my co-speaker, artificial intelligence is simply a machine that learns patterns from data, and it helps to be able to make some fast human decision making by recognizing patterns, particularly areas where tasks are being repetitive, right? So AI can process huge amounts of data in billions within a very short period of time. So the artificial intelligence is simply a tool, or you can also call it a machine. In some other cases, as well call it a software. So once you are able to engage this software by imputing some historical data, the software or the machine can then start making decisions based on the information that has already been provided. So tools that you already know. For those that probably are not aware of these tools, just wanted to point it out. Some of these tools act in various aspects. For example, your ChatGPT, your cloud, your Gemini, your Copilot. This can act as an agent or an assistant. When I use the word agent, you simply mean is that you can provide some specific level of information or data, and then you provide this specific level of data and information to these agents, and then you can put these agents to provide response based on the information that you have already provided. For those that you want to make research, you can make use of Perplexity. In terms of email, and you use that in an coding, you can use GitHub and Cursor. Also to know that these are just very, very small, numbers in terms of various tools that are very much readily available for use And so, the purpose or the objective of this webinar is to at first show you that AI is already part of engineering practices, irrespective of the profession. You're a civil engineer, you're electrical engineer, you're chemical engineer. There are certain workflows or certain activities that you're currently doing that AI can help. So this webinar is just to show you some of those areas that has been found to be very helpful, and then you can look inward some of your activities everywhere. And this data center consume huge amount of electricity. In the last decade, over 90% of new power systems that have been added worldwide are renewable, and AI is becoming part and parcel of every single deployment, and AI is reshaping our engineering practice. So the question is no longer whether AI is useful in some of these deployments. The question is, are engineering or engineers ready to lead the change and lead the application of artificial intelligence in their work stream? It is all known that challenge is very big problem that we're trying to solve in sub-Saharan Africa or Africa as a whole. We're seeing that the innovation and development in renewable energy has somehow been able to solve some of these huge problem or huge energy deficit problem. And we've been seeing the reintegration and deployment of renewable power systems such as solar, such as wind, in solving these huge energy deficit problem. However, it has been known that supply from renewables are somehow variable. Variable in the sense that, for example, irradiation from the sun is not constant. So it goes up and it goes down. So there is a whole lot of variability that comes with the supply from renewable energy sources. As a result of that, it makes output or power supply coming from renewable energy sources to swing minute by minute. Also, the fact that there is a decentralized power architecture for renewable energy sources, we see that power can be aggregated from different sources or from different assets in order to form a single source. And we're going to be looking at how AI has been added to solve some of these issues that we're discussing. Also, in terms of storage and timing, we see that we have a very short window to collect renewable energy power sources, and how is AI able to predict and forecast some of these window period and ensure that power is available for a longer period, some of the things that we are going to be seeing as we proceed. Modern grid generates huge amount of data that humans can read. Again, at the back of our mind, we should be asking ourselves questions. What is AI solving? Why are we applying AI to our work stream? Why do we need to implement artificial intelligence in what we do, right? You see that in modern grids, you have Internet of Things equipment, you have smart meters, you have data concentrators that sends huge amount of data. Now, this data can run into billions. As an engineer, you are in a SCADA room and you have a plant of about 10 megawatts. And this plant of 10 megawatts is processing huge amount of data from each of the substacks of the inverter systems, data from the transformers, data from the controllers or the AC controllers, data from the microcontrollers, data from the smart meters or the data concentrator unit. So you see that the amount of data being produced is so huge that making decision at a faster period of time becomes a whole lot of headache, and becomes too difficult to be able to make. And sometimes you need to process this data in order to make decisions, in order to prevent the grid you are monitoring from shutting down. So the bottleneck is no longer the data. There is huge amount of data to be processed. The bottleneck is how do we make decision at scale based on the amount of data that is available. So AI, or the artificial intelligence, is now being built into this architecture or into this grid in order to be able to make this decision, in order to press the decision, allow the engineer that is monitoring these systems to make judgments as quickly as possible. So the artificial intelligence is now a very critical component in managing big power systems or big power stations, and engineers who knows how to interface with these artificial intelligence devices or machine would have an edge over engineers who would have no interface with AI. Where do we have AI already used? Where AI already works in our field? In fasting, like I mentioned, assuming you are an engineer monitoring a 10 megawatt plant where you are faced with huge amounts of data being processed by different aspects of the power system, AI helps you in making decisions such as forecasting in terms of generation, demand, and weather. So most times, this artificial intelligence machine or software, they have huge amount of data that has been processed. For example, weather information. I'll give a very good example in design. I'll give a very good example in design and deployment. For example, you can have a design that on a normal day you spend about 2 to 3 days to finalize. Probably design that has to go through a number of engineers to review, to fact check and to inspect if all the necessary variables have been put into consideration. Right? With a tool like cloud, you can if there are no information that are not expected to be shared, you can upload that particular design to a software like cloud, and cloud will be able to tell you certain errors or certain miscalculation that has already been done, and this takes between 5 to 10 minutes, right? So in a case where you need to probably share your design with a couple of engineers to review for you, AI can actually do that within 5 to 10 minutes. So we see that AI application in some of the engineering workflows can cut reviewing of designs by almost 50 to 70%. So let's look at some live demonstration where AI tools have been applied in renewable energy and power systems. For example, as I mentioned earlier on, in design, a design that typically takes maybe 20 hours can be done within 5 hours with the use of AI. Same thing if you are preparing for a project. Probably there are a couple of documentations, project reports that you are supposed to produce, with certain information being shared with this information can be drafted within 5 to 10 minutes, which means that a report that you could have produced for 1 or 2 days, where you probably need to keep reviewing and ensuring that all information that's expected to be captured are properly captured. Within few seconds or few minutes, AI can spot errors such as numbers, such as probably where you are supposed to write 5 megawatts and you mistakenly wrote 5 M instead of 5 megawatts. So AI can help you to proofread even if you are doing engineering reports, and all these activities can be done with incredible fast pace. As also mentioned, AI is currently being used in power generation system to forecast. A well-trained AI agent about historical data such as weather and output can predict generation of solar and wind energy. To be specific, for those in the renewable energy sector, you now see that some of these remote monitoring or internet-based platforms now have AI agents and AI tool helping you to process data and also provides informed decision. A very good example is the DA Cloud that now has a co-pilot infused in the remote monitoring application. So you have an option where you can ask the co-pilot to manage the entire settings on that particular system, such that once, for example, the weather is not too good, generation is poor, the co-pilot can, through the backend setting, check if grid is available in that system and then ask grid to support. So instead of manually programming these settings on the power system, co-pilot that has been infused at the backend layer of the software can then take up the running of the plants by reviewing data by reviewing weather data, historic data, and also data as it is occurring, and then make projections on how to ensure that the power system can continuously deliver power. AI also has been seen to help to catch faults earlier on, and this can be done, as mentioned earlier, with the use of co-pilots to manage the operation of a power system by checking for vibration, checking for temperature, and also to flag if there is a potential inverter issue, and then make recommendation before a human would even notice. So typically, it can help to flag errors earlier and also prevent downtime. Also, we have seen the application of artificial intelligence in energy means. If you have a plant where you have solar, you have wind, you have grid imports, with artificial intelligence controlling the entire power system, it can help you to make informed decision, ensuring that the system is optimizing all the important parameters and ensure that your energy mix is well coordinated. In terms of forecasting, we have seen that it has helped to reduce forecasting error by 20%. Imagine you as an engineer, you're trying to process data of about 1,000. You're to process over 1,000 data with your spreadsheet and Excel sheet. You can imagine the amount of hours and amount of effort you are going to put in achieving that, and also the fact that even with the huge amount of effort you are adding, you are still prone to making about 10 to 20% of error. Now we've seen artificial intelligence softwares like Cloud and ChatGPT, you can impute them even in your Excel sheet and then ask the cloud to help you to analyze the amount of data that you are going to process. So this means that your forecasting errors or your spreadsheet analysis error can drop even up to 20%. Also for preventive maintenance, like as I mentioned earlier on, by allowing AI to operate your power system, you're sure that your downtime can be drastically reduced because the tool or the agent is making repetitive decision at a faster period and at a faster pace. Even before it happens, the AI is able to catch it and also is able to notify you ahead of time. So these are really, really compounding gains that we have seen in the application of artificial intelligence in management of power systems. How do we stay relevant as electrical engineers? As mentioned earlier on, AI is not going to chase electrical engineers who knows what they are doing out of their job, but engineers who can learn AI and apply in their work stream will definitely outpace engineers who currently do not. What AI handles at the moment, AI process millions of data at an incredible pace and time. AI also helps to make repetitive drafting and paperwork. For example, as a project manager, just dropping out of a meeting, what I just probably need to do is to take note of the key points of a stand-up meeting or a very important strategic meeting with clients. I just need to drop those points in an AI tool like ChatGPT, Croc, or Cloud, and in 5 minutes, an engineering report or even a technical report of that meeting will be produced. Now, what that does is that it drastically reduce the hours of brainstorming, the hours of checking for punctuations, the hours of checking for errors. AI can as far as even telling you, areas of improvement in the report and things probably that you did not catch, and then make recommendation. AI also helps in continuous monitoring. There are some setups you can do for repetitive processes where AI does it automatically for you, and you do not have to think about that particular task. At a set time and date, the report is being generated, and you just go to your tool, you open it up, and you review, and you make final changes, adjustment, and then you send to your stakeholders. So AI helps to handle, to even check certain patterns at scale. Incredible. You have huge amount of reports to prepare, or huge amount of reports to read, and probably you're going into a technical session and you have a couple of information to check or to review. You can share those information with your AI tool and then ask a couple of questions, areas you need to focus, and areas you need to work on, before you going into some of those sessions. So while AI is handling some of these very important tasks, as engineers, judgment and accountability still lies on you as an engineer. So whatsoever decision, recommendation that AI is giving you as an engineer, you must be sure that those recommendations are in alignment with what you know or what is very much obtainable. I think my co-speaker also made reference to regulation. For example, in Nigeria, the interconnected mini-grid regulation was passed 2 months ago, and as an electrical engineer, you're trying to fact check a particular regulation. I think the last was released 2015, and you ask AI to check the regulation and probably make a report for you on that regulation. If you did not provide that AI tool with the 2026 regulation, the AI will probably be referring to the old one, which is 2020, 2015. So it is also very important for engineers to be sure of the information that is being shared with the AI and ensure that the information that is being the information that is being reviewed and used must be updated so that you don't go and share information that is not correct. So as engineer, you must be very clear with accountability. You must also not share information that is out of that is expected to be confidential, right? Data across the world, right? So you must be sure that the information you are sharing with it is within the areas you are expected to share. Also ensuring that the final decision is determined by the engineer who's using that particular tool. So you must, be sure of the data and also the decision that you are making on behalf of that information. So what skill do we need to keep you relevant in a various field? So importantly, like we've said earlier on, there are so many, AI tools that are applicable to our different profession. As an engineer, you must review internally what are the AI tools that can help to ensure that my work is done much more efficiently. You must know the model and also the outputs that you're expecting. Also, in terms of adaptability of the tool you are using, you must use tool that you must use a tool that has a particular advantage over the other. For example, if you are doing more of generative AI, a tool like ChatGPT can be very, very helpful. If you are doing more of imaging, using ChatGPT can be a lot stressful because not that ChatGPT cannot do it, but it probably take you more time to be able to achieve, some of the things. So you must review first, look at the workflow in your engineering practice that you need an AI tool, and then look at the AI tool that can answer that particular or that can address that particular task. More importantly, as an engineer, we must use artificial intelligence responsibly. As mentioned earlier, the quality of data you're providing to this tool is very, very important. The input determines the output. So you must mind the data that you are sharing, ensure that the data is correct, it is not biased, because that is what will determine what your output looks like. As also mentioned, you must protect confidentiality. If you know that the information that you are sharing has some sort of confidentiality, please avoid sharing that kind of information with AI. As mentioned earlier, also AI is aggregating trillions of data across the world, and so such data can be prone to unauthorized use. So you must protect anything that is confidential, even as you are trying to use this AI to help to assist your workflows or your activities and improve your productivity. Um, Also, you must be accountable to your interaction with AI. The final decision you are going to be making still relies on you. For example, engineer Femi use AI, for example, to review a technical design. By the time that design is submitted to a client, engineer Femi will not say that it is AI that helped in reviewing that design. That design stays with engineer Femi. So even as the AI is helping you, the accountability of that workflow or that particular task that has been supported by AI still falls back to the engineer who is making use of that particular tool. And lastly, you must verify. Don't trust AI blindly. Sometimes the outputs is contestable. So most times I do tell people that, when you are interfacing with an artificial intelligence tool, you are interfacing because you have certain information that the AI does not have, right? So make sure that those information you are sharing with the AI is genuine, original, and at the end of the final output from the AI, you are able to proofread and be sure that the AI has not added any generic information from its database or information that is not related to what you have provided. So verify all output from your AI tools and don't trust it blindly. So in summary, the takeaways is that artificial intelligence is already practical. It is just for you to look at what you currently do as a professional and find an AI tool that can help to make certain part of your work to be done a lot faster and a lot efficiently. So the AI tool helps to amplify productivity. In fact, I remember a few weeks ago had this concept of a mobile app, and I was speaking with mobile developers, and they were telling me that to get a prototype out, it would take about 3 to 4 weeks, right? And then I started making research. I stumbled about an AI tool called Cloud. And then I provided the framework of this mobile app to this Cloud. And I can tell you within the next 5 to 10 minutes, Cloud gave me a prototype of the app that the software engineers told me to take about 3 weeks. So what that means is that, one, it has saved me time, it has saved me costs. The tool was able to give me how the mobile app would look like, even show me the different uh, segments of the app in visual, not just in words. It was able to show it in visual. And also, by the time that app goes to the software developers, maybe the cost I'm going to incur in finalizing or in developing the app will drop by almost 30 to 40%. So you can see that who are able to make meaningful use of this AI tool would help to improve their productivity at a significant level. More importantly, we need to keep learning. Tools are based every day. Software developers are looking at all the various applications of AI in workstream, and attending webinars such as this can also help to expose some of these areas where AI are already being used, and also areas where emerging technologies can be applied in the use of artificial intelligence. So I'll round up by saying that engineers who pair domain depth with artificial intelligence fluency would definitely lead the engineering practice. So our advice, and I would recommend, as I've said earlier on, whichever profession, engineering profession you're currently doing, look inward, look at some of these activities that you do that AI can come in to help you to fast track, to help you to optimize, and more importantly, help you to improve your productivity. At this point, thank you very much. This is the end of my presentation. Thank you, everybody.
Wow. That has been quite interesting, engineer. I have seen the forecasts. We have seen the forecasts. I think in Uganda, we are close. What is major is underutilization of our power that is generated when it comes to renewable power. And I think with that kind of technology and AI and what we know Nigeria for, this could be a good opportunity for us to partner. We invite you, such that our engineers learn that skill set on how to utilize all the power. Thank you. You talked about sub-Saharan Africa, and I realized that on call we have the ambassador of PMI construction professionals of sub-Saharan Africa, Mrs. Bereket Lydia. I hope she's still on call, but she was there. And in regards to our partnership in terms of improving on the utilization, given the statistics, the graphs, the bar graphs that you have shared, we also had Engineer Olara Oscar on call, who is one of the stewards at the National Planning Authority of Uganda. So I think he will pick this up, and then we can see how we can work together. At this juncture, I know there may be a number of questions, but I would like members to guide. We are supposed to have ended at 12 p.m. And I don't know what members think. I would kindly request that if we can increase or have more time, about 30 minutes, to 10 of which can be for Q&A. Probably we have 2 minutes, maybe from the PMI team to say a word or two. And then, yeah, we can give our parting remarks, maybe in 1 minute each or 1.5. And then should there be announcements, we have that. And the president comes in to close. I also recognize our colleagues from Nigeria. I have seen Chigozi. In Uganda, there is a tribe called Buganda that has Chigozi, but with K. This time I have seen Chigozi with CH. You're welcome. Yemi or Peyemi, you're welcome. You're welcome. Thank you. Members, should we increase the time by 30 minutes or you're only giving us 20?
So interesting. We can add even more.
We can proceed?
We can add more.
Okay. 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 Thank you. Thank you. Thank you for accepting that request. And at this juncture, I open the floor. Members are free to raise questions, additions, but let's mind time and be snappy such that at least we have a number of participants make submissions. For those that will not be addressed, we can type them in the chat, and the slides and presentations shall equally be shared just like it was said. Thank you. You're welcome. You can just raise up your hand and then we see who. I do not see any hand. Was it one-way communication? Yes, yes, Oscar, Engineer Oscar, please, you can go ahead and make a submission. Thank you. And
the presenters, and of course, recognizing UIP president and members who are here. Mine is simple. Today, of course, from where I work, we're seeing a lot of people using AI. Of course, the regulations are coming slowly. But another thing is that as people use AI, especially in engineering, of course, gives you quick results. My only challenge comes in at the people who are supervising these engineers. For example, you're maybe a client. How can you be able to prompt and see the gaps? Because like already been mentioned that you have to be deep in your domain. At the same time, you should also not use AI. But now, especially today, where most of the people at the highest level are not exactly, they're deep in the domain, and they might have the time to look through the voluminous work that is involved. How do we help them to use AI to actually critique these other projects that come quite thick and fast? So my issue is, like, for example, I'll give an example, like in an institution whereby, like someone said 45 plus, 50 plus, you have been an engineer with 30, 40 years experience, and it's an engineer who has come to bring for you some designs to review, and you used AI. How can I also quickly use and have a shorter turnaround time to be able to critique and understand and maybe give feedback the shortest time possible? Thank you.
Okay, I think we shall take some 5 questions before an answer can be given from one of the presenters, maybe Sabiti. Engineer Godfrey, you're welcome. Make a submission, please.
Yeah, thank you very much. I do not have a question. You're speaking to the converted. I am very, very deep into that field. And I just wanted to give you a regional perspective at the East African community in terms of the countries that we serve. 5 of the countries already have some regulations in place in terms of data protection, data governance, cybersecurity. We are helping the other 2, the other countries, remaining countries, 3 countries out of the 8, to support them. These are majorly new countries that joined the community. That includes the Federal Republic of Somalia. And we have developed the ESE Regional Artificial Intelligence Strategy running from 2026 to 2031. Alongside, it's one of the key components in the regional development strategy for the East African community. So I want to implore engineers, please, you've heard the message is very clear. I won't labor to repeat it. For you to be able to know what is not AI, what is AI, you need to learn AI. That's all I can say. Thank you. I beg to submit. I appreciate the presenters. Wonderful presentation. Thank you.
You're welcome. Thank you, Engineer. Mahad, please go ahead and submit.
Yes, good afternoon. Good afternoon, FXB. My name is Mahad Anyole. I am a student of electrical engineering at Busitema University. So my question is to the presenters. First of all, the presentations were very wonderful. We as students, we have a challenge of just using these AIs for basically question and answer. Maybe you have presentations in class, that's what you use them for. But I would like to know how best can we learn these things? What strategy can we use to learn them so that we can integrate them in what we are learning, like what we are studying, and we can use them in the field as well? That is my question. And maybe to you, Mr. FX, can we get a recording of this after? Because they have been very insightful and very, very good presentations. Thank you very much.
Okay, you're welcome. Engineer Femi, do you want to pick up from the student, Sabiti? The questions in the chat, you'll handle them. And I think you'll also handle Engineer Oscar. Thank you. Engineer Femi, can pick up from the student. Busitema, for your information, is in the far east of Uganda. Thank you.
Sorry, Francis, I'm trying to remember the question, but I know someone mentioned how to pick up the learning on the artificial intelligence. I just wanted to be sure that was the first question.
Yes, that was it. How are you able to see the gaps? The first one was, how are you able to see the gaps and critique from other projects, especially as a stakeholder, like a client?
Okay. So I'll start by saying that thanks to professional bodies like UIP, Project Management Institute, I think 2 to 3 years ago, started the journey on artificial intelligence. So for those people who are a member of PMI, I know for sure that they must have done a couple of training, data science in project management, generative AI. In all these courses are available on the PMI learning course platform. I think you can just go to the PMI learning platform. They are all free and they are all PDU They're all PDU courses. So just start your AI journey by looking through some of these courses, right? So I can tell you most of them are practical. You'll be introduced to different tools, and then you can start reviewing which of those tools can address some of the workflows that you currently do at your work or at your workplace. So the start is to go in and look for courses on AI. As engineers, I know we are we are fantastic people. If we can learn coding, we can learn Laplace transforms, we can learn all these Schrodinger equation. AI learning AI is one of the easiest that we can actually learn. So the start is just to go for AI trainings. I'm aware that a lot of online courses have AI, introduction to AI or introduction to generative AI. Just start from there and then start courses upon courses. Already start with some of these AI tools. You don't have to pay, go for the paid version. As Christopher also mentioned, you can start with the free plan, and then as you learn, you a lot of things will start coming through your mind on how you can apply some of the things that you are learning. So start with courses, online courses, and then you can build from there.
Thank you for that submission. Christopher, do you have anything to add on that? Anything specific for the student and to the chat?
I think not much, but I would also supplement to what Defemi has said. You need to start small, and I like the response from Charlie in the chat that the first thing you have to change is the mindset. We have been in an ecosystem that people are fighting AI, that it will not take our jobs, and you feel like I don't need to engage myself with AI, but you just need to change the mindset. Then there is a question that came: what skill do you have to learn? I think there is nothing much like a skill. It is all about to pick up mindset and start learning small. What I can say, start with just prompting AI. Learn the way how they prompt AI. That methodology that you have to learn to give AI. Like you give it a role, you give it a context, you give it constraints, what it shouldn't do. When you coming up with the context you need, like writing an email and all that. The same AI can teach you how to use it, by the way. Just go to Notebook LM, just go to ChatGTP and ask it, please teach me how I can start prompting you right, such that you give me exactly what I need. It has already learned how to do the engineering prompting. It will give you exactly what you need to do when you're prompting it. Then the other member has asked on the starting point where members can start. I think the Femi has answered that. Start with the tools. You have the chat tools. Then slowly start shifting by using it in some of the applications you're using that you run with your profession. I can tell you most of the applications have been now embedded with a lot of chatbots. Obviously, we have restrictions here and there with the different governance and companies we are working with, but all this is going to be opened in bits when you people embrace on how to use AI and also governance, data protection. There is a lot it comes with you, how you're using AI. Don't give company data to AI because you want to quicken on a report. There is a way you can structure it. You get the report done in real time without sharing the company data with the AI model. Then someone was saying, I think it was on Mon project, how do AI models handle informal constraints like budget limits and material shortages? As we have already said that AI is there to learn and be trained. So the quality of inputs you give it is what it will give you. The moment you just dump the budgets not yet streamlined from the different departments, it is going to get a lot of strain to come up with the accuracy you needed. So you as a human, you need to put in that concept that I need to rearrange the data well. That's where now you need to have at least a bit of basics in data and reporting. Using tools, how you clean data and give it a clean concept, then it can run for you a clean report. I know questions are still coming in, but that is the brief I can give. Edefemi, maybe is there anything that you can pick up from the chat? Maybe to do more on the engineering. Question from Wazwa: how do engineers reconcile their role with non-engineers who empowered by AI are increasingly able to perform engineering-like tasks? I think I would love that an answer to come from the engineers. In brief, is how do you manage to correlate with the people already who have used AI and can go in a building and do the electrical installation without any certification and license? When you're the profession, how do you manage this? I think now there it comes with the body UIPE. How are you managing this to stream and have these controls put in place? Like I can say in systems where I am, in systems where I am, we have vibe coders who are producing apps everywhere. But at some point, there is a regulations that keeps them in check. Okay, you can take it on.
Thank you. Thank you.
Okay. It's okay.
Go
ahead.
Oh, okay, okay. Thank you, Christopher. I think engineers should view AI not as a threat to their profession, right? You see, AI can help non-engineers in many engineering-like tasks, right? But the truth is that engineering is beyond information processing, right? Which is core of what the AI would actually do, right? But engineering professions are responsible for a number of activities that the AI itself will not be able to perform at scale. You know, the most important thing is that the judgment of every engineering task, right, cannot be left to an AI to make, right? So an engineer has to still make those decisions. So irrespective of the application of AI by non-engineers, the fact remains that there are some critical decisions that non-engineers will not be able to apply or even to contribute to, especially technical analysis, preliminary decision making. Typically, non-engineers will not be able to non-engineers will not be able to make some of those decisions. So the eye is to provide speed, efficiency, broad knowledge access, but engineers provide the technical rigor, the risk management, and professional accountability. So there's no way, even with the use of AI, non-engineers can still not compete with engineers. Thank you.
Colleagues, thank you so much. We had one question from Mrs. Bereket, the Global Ambassador, Sub-Saharan Africa, but I think because of network, she has gone. In that interest, allow me state that we have combined two aspects on the agenda, which is the discussions and the takeaways. If you looked critically in the presentations from Femi, there were some takeaways. So we shall not go back to that, but only share the slides at this juncture. Allow me just to call on the VP of PMI, Innocent Rwamwizi, in 2 minutes to say a word or two, because we recognize his presence here, being partners in the project management space, after which we shall have also a strategic direction of UIPE when it comes to this. Thank you. Innocent, are you there? In a minute or two.
Thank you very much, Francis. Thank you, Can you hear me, Francis?
Yes, I can.
Okay. Thank you, the guest speakers we had. And I have learned a lot. And what makes me more proud, of course, is that the guest speakers are PMP certified professionals, and who else will do it better than them? I want to thank the president. Thank you very much, President of the Association. I listened to your opening remarks, and I was humbled. I want to thank everyone who's on call, my colleagues from PMI. Thank you very much for joining. I want to say something that if I could just, I don't know whether I could just share something small here. Chair, can I just one slide? May I?
Go ahead in a minute.
Are you able to see that slide, Chair?
Yes, please.
And are you able to see my cursor?
Yes, please.
So I just want you to pay attention to this cursor, this chart, along that chart, to give you an idea that before I tell you what PMI is anyway, to just give you an idea that at PMI, Project Management Institute Uganda chapter, that majority of our members come from the engineering fraternity. If you look at construction, is leading by 261. If you look at energy, is 189. If you look at IT, is 138. If you look at telecom, and so forth. Literally, when you're talking about the engineering community in Uganda, you're talking about a brother who is Project Management Institute. I can stop sharing. Okay, so why did I have to share with you that slide? Is that we are inseparable as a Project Management Institute, and an institution that brings together certified project managers. Our previous 3 presidents were engineers, and it is not surprising that nearly more than 60% of our members are engineers. Who are we? Project Management Institute, as I said in a minute ago, is an institution that brings us together, certified project managers and members that intend to become certified project managers. Why is it important? There cannot be engineering without project management. So, President, I want to officially invite you. I know my other colleague on call would have done that, but I want to invite the president of this association to our upcoming national conference happening on 7th August at Mistil. And I'll personally, after this call, engage with him to ensure that this invitation is personal. And why is this important? Is because you can't talk about AI in engineering and you don't talk about PMI. So we are a huge and very important chapter that brings together all certified project managers in the country. We are part of the global brand of PMI, Project Management Institute in the US. We are a growing association. We have about 2,000 members, and we are unstoppable. So we want to thank the UAP for inviting us to have just this brief introduction of who we are, but also to appreciate the contribution that engineers make in the field of project management. We intend, I want to use that word, to establish a very good relationship with the association. And we believe that together we will leverage on our resources to ensure that we promote the interest of both entities for the better of this country. I'm introducing myself last. I am Ramwiza Innocent. I am a vice president of the Project Management Institute Uganda chapter. I bring greetings from our president, Disan Katawara, and the VPs that are here, and some of other members that were able to log in this conversation. Thank you very much, Francis, for this opportune moment to tell you about PMI and the good things we do. And we hope that in future, this conversation will be jointly organized, or make sure that it jointly benefits both institutions. Thank you very much, and over to you.
Thank you, Innocent, for that submission. We are happy to be your partners, and we are happy and humbled that we contribute a big percentage of your space. We hope that can improve. We aspire to collaborate across all fronts as engineers, because economic development is driven by technocrats, which is what we are looking up to moving forward. At this juncture, allow me invite the president to give us closing remarks. And before that, allow me give my closing remarks, because once he has spoken, there will be no other speaking. I thank everyone who has turned up here, the executive committee of West Nile, the executive committee from all other branches, all members, PMI, those who have come in from within and without the country, from within and without the continent. We appreciate the time you have given us, especially even with the constraints of the time zones. Thank you, thank you, thank you. God bless you. Engineer, you are welcome to give us the closing remarks and have this ended. Thank you.
Thank you, FX. I don't know why I very much want to say Engineer FX, but I know that is coming. But thank you very much for leading us very well. Thank you, colleagues, for the engagement. Thank you, our presenters, for preaching the message. I think it's very loud and clear that there is a very big shift. And so you must be able to perceive it and to move accordingly and to overcome any form of resistance, because ultimately AI is here. It can only get better, it can only improve. So thank you very much. I just wanted to say that I've learned a lot from this session, from our presenters. Myself, I'm an electrical engineer, so I was very excited to see the kind of areas where AI is coming in to transform things and to improve our practice. I was very excited to see Engineer Godfrey Zama, and Zama and I were on campus at the same time. It is after we graduated that I discovered he has a third name, Addison. So we had always known Nzama. Somehow we had to graduate and then a third name, and I think a fourth name showed up. But it's always a pleasure to see you, brother, and also to thank you for the wonderful work that you're doing at the regional level, at the ESC. Related to that work is the aspect of mutual recognition of engineering professionals at the ESC, because there is a process which UIP is participating in together with the other institutions at the ESA level. The idea being that if I'm a registered engineer in Uganda, then I should be able to practice under the, the common market protocol across the ESC. So there's a lot of work going on there. And I think very soon we'll be making an announcement if it hasn't been made. But briefly, there is a platform which has been developed where we shall be able to enroll. So on that platform, if I am in Uganda now and I want to go and do a project in Kigali or in Somalia or in South Sudan, then from here I can actually apply and log in and apply to the competent authority there, which would be like a registration board. And then I can receive a license even before I go. Of course, the question becomes, because I can sit here and do a project in Kenya, even without traveling there. So thanks to AI, I can actually practice in Tanzania by sitting here. And so there's a lot of discussion on how the practice is going to be regulated. But I thank you, Engineer Izama, for the work that you're doing. Then Innocent at PMI, thank you for the invitation of 7th of August at Mistil. I accept the invitation and I'll be there. I trust that the letter will come through when it does, but we'll be happy to partner. As a matter of fact, I don't know whether you know Engineer Irene Natabi, who has done a lot of good work with PMI.
Yes, I know her. I know Engineer Irene, our previous.
Yes, and my vice president in charge of membership education and training is Engineer Diana Kessiga, who is I think a PMP.
Yes,
I think I'm the only person who is supposed to become PMP, which is something I'm working on. So we are very switched on. We are more aligned than you might believe. As a matter of fact, we are already having conversation to say that the PMP courses can actually be accredited and be part of our training calendar and be able to earn CPD points. So it's just that we've not reached out. But I think once we reach out, we should even be able to have a memorandum. Absolutely. Because we're already having those conversations. So thank you, and I look forward to joining and supporting each other.
You're welcome.
Finally, before I close, I wanted to tell members that the current leadership at UIPE, I don't know whether colleagues know the word cynicism. So to be cynical is to keep complaining that why things are so bad. You know, what are those guys doing? You people at UIP, what are you doing? We are actually committed to making some changes and also to give a voice to the profession and also to reach out. So if you know, because you see, changes may happen and you do not see them, or you do not realize that there are changes going on, to give a platform to the profession, but also to make sure that we create opportunities for members. We address the member concerns, the member challenges, the registration process. I don't know whether colleagues would have seen that we are already making changes. I think somebody shared the process workflow. I don't know whether it was shared on the branch page of how
yes,
you.
It was Chair, President. Sorry.
Okay,
It was shared.
so that was taken out of a document which we should be discussing in council on Tuesday this week. So that thing is one page of a long document, but we are already discussing certain reforms so that the process flow, which is something Innocent would understand. We have to make the process flow very clear of how do you come in as a technician, as a technologist, as a graduate member, the complaints about the fees, the high fees on our trainings, and so on and so forth. These are issues that we are thinking about. So we ask for your patience, but we also ask that you abandon the idea that things do not change and people at UIP are just doing nothing. We'll hope that you give us positive feedback on how we can improve. You critique us, but also you support us. Then before I close, you can permit me I'll share my contact. I mean, please don't call me for everything, but I mean, if you've submitted your application and you're not getting feedback, then I should be able to make sure that our staff serve you. So I'll just share my contact. Please reach out, okay? If there is a challenge, don't say, I submitted an application 4 months ago and I'm here, I'm stuck. No, but I think you're also part of the problem, because why haven't you reached out 4 months later? So please reach out, engage us. We are here to support you. And we also want to be transparent and objective in the way that we serve you. So I'm on 701-286908, 701-286908, and 776, same number. Reach out to me But of course, if it's a membership issue, reach out to Regina. Maybe we should publish the contacts that you should reach out to. Please reach out to the president only when you're not receiving support. Otherwise, I'll be overwhelmed. So with that, thank you, colleagues, and have a blessed day. May God bless you. And yeah, we look forward to many such engagements. And of course, we pray that one of these days we'll even be hosted physically, and we come and do some of these meetings physically, and have more person-to-person engagements, because we are still Africans. This person thing, yes, technology is there and AI, but sometimes we have to sit and have a meal together, and enjoy each other's company. So God bless you. Thank you very much. Back to you.
Yeah, welcome, Mr. President. You will definitely be invited to West Nile physically, including those abroad. Have a blessed day, team.